And so what is today's topic? Today's topic is probability. And what is the study of probability about? Well, it's really about taking things that are uncertain, and normally we say uncertain events. So taking uncertain events and quantifying them. Quantifying. Now, quantifying sounds like a fancy word. Another way of saying that would be give it a number. Give it a number. And the number, say the number tells us the likelihood. So the likelihood the event will happen. Now that sounds all a bit wordy. So let's go back to the important bits. So there's something that's uncertain that we're not sure about, and we're trying to quantify that. We're trying to give it a number, and the number tells us the likelihood the event will happen. Now, what I want to ask in the chat is, what is the range for my number? So if I'm going to give something a number, I want to know what is the range, in what area does this number exist for probability? Or what we might say, what is the probability number scale? Maybe you've heard about it before. If you know, put something in the chat and tell me what numbers that you heard go with probability, or what number scale. Maybe your teachers told you about something. I'm curious to know what people have been learning in their classrooms. What numbers do we normally use to represent the uncertainty of an event happening? Okay, Morgan and Dudu. So percentage, I see the percentages come in. Fractions, yep. Absolutely, keep those suggestions coming. So it's a little bit confusing because there's actually 3 different ways we can write it. And so what I'm going to show you, decimals, yep, fractions, you guys are all in the right ballpark, decimals. So what we normally talk about is we talk about a probability scale or a probability line, and you guys are all getting at this. And the scale really goes from 0, which is the event is impossible, all the way up to 1, where 1 is certain. But sometimes we can write that as a decimal. So if we wrote that as a decimal, 0 would be 0.0, and this would just be 1.0. And in even chance would just be halfway in between, would be 0.50. Okay. Now, the probability scale, let me actually write what even, so a half would be halfway in between. If we use the decimal scale, we would get 0.5. So we have, let's say we have the common fractions. Oh, I don't know why am I. The common fractions. We have the possibility of using decimal numbers, or we can use percentage. And percentage will look like this, where this will be halfway, or an even chance would be 50%. This would be 100%. Oops, I wrote that wrong. 100%. And this would be 0%. So there's actually 3 ways, but all of these 3 ways are express possible events between 0 and 1. Okay. Now, I want to ask, if we go to a place on the number line, let's say an event is unlikely to happen. I want you to give me a probability, a rough probability for an unlikely event based on the scale. So type in the chat, what do you think the probability of an unlikely event would be? Aha, I see those answers coming in there. So an unlikely event is going to be somewhere down here, right? Now, I didn't give you an exact, the example they give is a 1 in 6 chance. Now, 1 in 6 chance so is going to be written like this. If you want to write it as a percentage, you could write that as what maybe somebody can tell me by putting in their calculators, or some of you are writing 25%. 25% would be the same as 1 in 4. And that's also going to be down in the unlikely territory. What do we get for 1 over 6 on your calculator? Is it 16.6 recurring? Have a quick little look for me. What do you get for 1 out of 6 on your calculator? Or 1 out of 6 as a percentage? I think it's about, yeah. So that would be about 16.6% recurring. So these are what we would call unlikely events because they're down here closer to 0. And then up here, as you get closer to 1, your uncertain events get more and more likely. So they give an example of a 4 in 5 chance being likely, and 4 in 5 chance would be the same as 8 out of 10 or an 80% chance. So 8 out of 10 times, given the same situation, 8 out of 10 times it would happen. Okay, so that's the basics of the numbers that we assign to an uncertain event. Give me a thumbs up if you're following so far. Give me a thumbs down if you feel like the numbers, what I'm talking about, doesn't make sense to you. Because this is the basics of probability. We need to give a number to an uncertain event. Okay. Now, obviously, we need a more methodical way of dealing with this. So when we talk about events, what we often do is we use, we give a letter to a particular event. So an example may be, in fact, I'll give you this, I'll show you this question. So the probability formula that we use to calculate the probability of uncertain events is the number of outcomes available, a number of outcomes favorable to A divided by the total number of outcomes. And A is just the event. So let's have a look at this one over here. It says, a dice is thrown once. Now, if I throw a dice, what are the total number of possible outcomes? So we're going to try and get this bit here. What do we think the total number of outcomes possible when you throw a dice? Okay, so that's going to be 6, because you could land on 1, 2, 3, 4, 5, and 6. But we must be careful here because some of you are falling into the trap here. The next part says, what is the probability that the score is a factor of 6? Now, when we think about the numbers on a dice, one of the notations we can use is to use the S, or the sample space, to indicate all possible options. And then we're going to use the letter A to represent the favorable outcomes, the things that we want. And the favorable outcome comes from the question, what is the probability that the score is a factor of 6? Now, all the options are 1, 2, 3, 4, 5, 6, which gives us 6 options. But what numbers are factors of 6? Well, I think 1 is a factor of 6 because it divides into 6 exactly. I think 2 is a factor of 6. I think 3 is a factor of 6. And 4 and 5 do not divide into 6, but 6 does. And so the number of outcomes favorable to A, or the number of things in A, is going to be that set. So now we ask ourselves, how many outcomes are there here in this block? How many if I'm throwing this dice and this is a favorable outcome for me, how many items are there? They're going to be 4. So what is the probability that I have a favorable outcome? Which of the 4 options here is going to be correct? I don't see a 4 over 6. What's going on? Well, the favorable, the 4/6 is equivalent to 2/3. And that means the answer must be C. Now, that was sneaky because a favorable outcome, the question was a bit sneaky. And so you have to read that question quite closely, and it can be useful to represent the outcomes in terms of sets, where you list the items. Another bit of note, let me just do a quick little vote. Thumbs up if you feel like you followed that. Thumbs down if you feel like you're still confused by that idea. Okay, awesome. Well done, everyone. Another cool little thing I want to throw in is some extra notation. If I say to you, what is the N of S? What that means in probability is what is the number of elements in the set S? So what is the N of S? It's going to be 6. What is the N of A? It just means what is the number of elements in A, and there are 4 elements in A. Okay, so that's just some extra notation. And you're going to see me throughout these 6 lessons, I'm going to keep coming back to this formula. This is really the only formula that you really need. I mean, there are other ones, but this is the granddaddy of all formulas for probability. So that's the one you need to know. Okay. Now, I'm going to come back to these words a little bit later. I'm not going to worry about them for now. I want to do some more questions. My computer crosses me, so let's see if I can make it less crossed. No, it's staying there for now. Okay, here is another question for you guys to have a go at. This is a spinning top with numbers 1 through 5. And I want you to read through the question, and I want you to choose an option in the questions here. And while you're doing that, I'm just going to switch across to my internet. Okay, I see the options coming in thick and fast. I want to ask, what are the possible outcomes here? It seems like the possible outcomes, and I'm using the letter S for the sample space, are 1 to 5. The spinner is spun until it lands. What is the probability that it lands on an odd number? Now, I'm going to use the letter O for odd, just to indicate that. And for me, the odd numbers are 1, 3, and 5. And so the probability of landing on an odd number, and notice how I say P for probability, O for the set, is going to be the number of possible outcomes is 5. The number of favorable outcomes, which is getting an odd number, is 3. And so the correct answer should be D. Okay. So it's that same formula again. You're just using it again. Okay. Let's do another one like that. I think I saw mostly. Please let me know in the chat if things are going a bit fast, but I liked what I was seeing there, and I feel like I must keep going. So here is another question. This time you have got an octahedron dice. So this is like one of those funky dice that you get in those cool board games, and it's got the numbers 1 to 8. I want you to try and work out what you think is the correct answer to this probability question. The question is, what is the probability that the face that lands uppermost has a prime number? And I'm going to let you fly solo on this. And if anybody is willing to share their thinking, I'll take some feedback from students if you're willing to put your hand up and you can talk us through how you did it. Yeah, I'm going to unmute Keisha. Keisha, what did you do to solve this question?
Hi, sir.
Hey.
I have a question.
Okay, go ahead.
You wrote n lowercase n bracket 6. What is that? Like
Lowercase n, let me just scroll up again. Where was that? Over here. Further up.
yes.
Oh, that just means n means the number and s is the sample space. Let me show you in this example. So in this example, oh, sorry, my thing ran away from me. Let me just turn off the. So in this example, the sample space would be all possible outcomes. Are you happy that the only outcomes for my octahedron are 1 to 8? Does that make sense to you? S is just a letter I'm using for the sample space, or what all possible options.
So would they ask us something like that in the exam?
So no, it's just notation. So I'm just showing you that n of S here would be 8 because there's 8 items inside the set. And this is part of probability notation. But if we have to do the question now, the question comes back to calculating a probability, and there are 8 possible outcomes. But now I need to know not just how many possible ones, I need to know how many prime numbers. So which of the numbers from 1 to 8 are prime, do you think? I'll get you started. 2 is the first one. So 2 is a prime number. What other ones?
Isn't 4 a prime number too?
So 4 is not a prime number because 4 has 3 factors. Your own prime numbers only have 2 factors. So 3 would be a prime number.
There's 3 and 5.
Perfect. Okay. And which other ones? Is there one
7,
more?
there's 7.
Yes. Okay. So the probability of getting a prime number, there's 8 possibles and only 4 of them are prime. So the probability of getting a prime number is 4 out of 8. But there's no 4 out of 8 as an option here. So which one do you think it is?
C.
It's not the
half.
Yeah. Perfect.
Okay.
Because it's equivalent to 4 out of 8. Well done. Nicely done, everyone. So the correct answer is going to be C, or half. Okay, so this is what it means to do probability type questions. Let's just get a quick vote. Thumbs up if you're following, thumbs down if you're feeling a bit lost. Let's just do a quick check-in, and then I know what I'll do for my last question before the break. Okay, fantastic, fantastic. Tando, I see your hand is up. While people are doing this next question, so I'm going to ask you to try and do this. I'm going to take questions and comments from students. So can we unmute Tando?
Hello, sir.
Hi, Tando. How can I help?
Sir, regarding the previous question, why was 5 and 7 included?
Okay, so the question for the previous one, let me just quickly bring it up so that we have both on the screen so we can work at it. The question was about prime numbers. So in the collection, in the numbers 1 to 8, 2 is a prime, 3 is a prime, 5 is a prime, 7 is a prime. A prime number only has 2 factors, the number itself and 1.
Also, in the sample space, you don't just list factors of 8.
No. Well, the sample space is all the numbers from 1 to 8. And then a favorable outcome is getting a prime number. And so that's why 4 is favorable, and 8 is just the whole like possibility.
Okay, thank you.
Pleasure. Okay, what do we think? So each of the letters of the word Mississippi are written on separate pieces of paper that are then folded and put into a hat and mixed. One piece of paper is chosen without looking. What is the probability it is an I? Now, I think I'm going to have to do some counting here. 1, 2, 6, 7, 8, 10, 11. So there's 11 possible outcomes. Which ones are favorable for me, given the event question? So I want an I. So 1, 2, 3, 4. So it looks to me like of those 11 pieces of paper, 4 of them are happy days for me. And so I'm going to put a 4 here. Now, is there an option that matches that? There is. And it's going to be an A. Okay. Let's do one more before the break, because you guys got that very quickly. Let us do the last one before the break, will be this question. Okay, so now you may have played card games before, and when we take a card out the pack, that is an uncertain event because it's uncertain whether you'll get a king or a queen or something. So what they tell us is a deck of playing cards has 52 playing cards, and there are 4 queens and there are 4 kings in the deck of playing cards. And that sounds, from the cards I've played, that sounds pretty normal to me. The question is, what is the probability of choosing a card which is a queen or a king? So you are happy, or life has been favorable to you if you get a queen or a king. And remember, you're choosing one card in the pack. You don't know what it is. It's uncertain. We're trying to quantify that uncertainty with a number. What do you think of the 4 correct options here would be correct? So let me think about how I would do this. My probability formula, and sometimes people would even write like something like K or Q because it's the probability of a king or a queen, and the possible outcomes are 52. That's kind of easy. Now, what do we think that's going to be over there? Well, Elichle, yes, I think that's 8. But now I don't have a 52 here, which must mean I need an equivalent fraction. Now, I'm pretty confident 11 doesn't go into 52, so I'm going to get rid of that. Now, which of the remaining options? Suppose our calculator can help us. The people of the room are saying B, and I agree with them, because you divide 52 by 4 and you get 13, and you divide 8 by 4 and you get 2. And so the correct option would be B. What is 2 out of 13 as a probability, as a percentage? I wanted to know this probability as a percentage. Could you tell me what 2 out of 13 is as a probability, as a percentage? Pop it in the chat what you think it is. What are we getting? So we should get 15.38%. Now, is that even? Is it unlikely, or is it likely? What do you think? What word would you use to describe that? 15.38%. If you think back to the beginning of the lesson, is 15.38? It's unlikely to happen. It does happen, but it's not an even chance, and it's not likely. So I would probably say it's more unlikely at this stage. Okay, give yourselves a pat on the back. You've done really, really well. It's now time to take care of your brain. And so I want you to stand up with me. And I want to know, Kia, who is the most enthusiastic participator in the room as I go into our exercise time here. Please give some shout outs to the enthusiastic students in the room. Okay. So I want you on your feet and I want you to join me with a little bit of a arm swing. And let's have a little twist. And as you get looser, you can find yourself rotating more. Okay, let's do a little leg stretch. So what you can do is you can just stand and you can stretch out your quad. It's a nice big muscle. And you can stretch out the other one. So stretch that out. Okay, let's do that. And then let us do some air skipping. So we're going to do 20 air skips. Okay, 3, 2, 1. 2, 5, 6. And do 10 more. 1, 2, 3. And there we go. I hope that your body feels alive and that you've got some blood and oxygen circulating around. Your brain break for today is to try and work out how many squares do you see in this square. So that is your challenge question. Who was my most enthusiastic participant, or who were the top 3? Who can
I liked Annie because she changed the direction when she was skipping. So
okay.
Wow. And then I can't remember the other person,
okay.
unfortunately.
So those were the students who were bringing it. So that is fantastic.
100%.
Well done. It's good not to take yourself too seriously. It's one of those wonderful lessons to learn in life. It's good to be able to indulge your silliness sometimes. And your brain appreciates it, I promise. So how many squares do we think we have? Well, I mean, I kind of can see 9. And then I can see the one big one. But I'm afraid the answer is not 10 either. It's a few more than that. So how many squares? Well, I see some people are saying 14, some people are saying 11. So I definitely see a square here, but you can also get a square here, and you could get a square down here, and you could get a square down there. So that for me gets us up to 4. And I can't see any additional squares after that. So for me, I think the grand total of how many squares there are is 14. And I see that Lalita and Sean and Azra and a number of other students agree with me. And so, yeah, just to recap, it's 1 for the big one, it's 9 for the little ones, and then there's these 4 squares that fit over there. Okay. Awesome. Question, Mzwandile, let's unmute you. What is your question?
Say, how did you get the 1?
How did I get the 1? So big, if you look at this big one, this is a square, that's the biggest, that's the 1. And then the 9 are these ones. And then I also have a square to get by going like 1, 2, 4, and 5, 2, 3, 5, and 6, 4, 5, 7, 8. Does that make sense?
Yes, I understand. Thank you.
Okay. I think that perfect. It's a pleasure. I love this question because it's like, it's simple, but it's sneaky. All right, let's go back to our lesson. Where were we? We were mastering the basics of probability. Now, sometimes questions get a bit more tricky, but let's have a look at this question. So if I look at this question, I want you to read through and tell me what makes this different to the last question, or what makes it, yeah, I'm curious to know what you think. Let's read it, and then you can tell me in the chat, or you can put your hand up. What makes this question different? A fair coin is tossed 3 times. What is the probability of obtaining 1 head and 2 tails? A fair coin is one that is not loaded, so there's an equal chance of it landing heads up or tails up. So they basically are saying they're tossing a coin 3 times. I'm sure you've all had coins before. What is the probability? So that's the number. What's the probability of obtaining 1 head and 2 tails? So there's there's actually a whole bunch of things that have to happen for a favorable outcome. What do we think is different about this question compared to the last one? So for me, it's not, let's have a look at I see answers or options are coming in. It feels like it's harder to keep track of what's going on here. So what I want to suggest is that we invent a tool to help us. If I was tossing a coin 3 times, let's pretend I toss the first coin and there's 2 options. The 2 options are heads and tails. So that's the first time we've tossed it. And I'll even say the first toss. Then the second time we toss it, represent those 2 options. So I'll say the second toss, I can have heads and tails, heads and tails. So far, I'm drawing a picture to help me understand what is even going on in this question. Give me a thumbs up if you followed my logic so far. Let's unmute Umdudu. I want to see what the question is. Umdudu, what's your question?
I think it might have been a mistake.
Okay, no problem. So what you notice is that for this question, no problem, is that because you toss the coin 3 times, there are actually quite a lot of possible outcomes. But I don't think it's impossible to see that if you look at the end, this is called a tree diagram. And a tree diagram is a way of us visualizing the possible outcomes and the favorable outcomes for an event. Now, the event that we have is a compound event. There are more pieces inside it. But I want to ask you, how many possible outcomes are there if you toss a coin 3 times? And I want you to try and use the tree diagram that I've just drawn here to help you. So how many possible outcomes are there for a coin that is tossed 3 times? Pop your answer in the chat of what you think. So I think that you could have heads, 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 which is that one. You could have heads, heads, tails, which is that one. You could have heads, tails, heads, which is that one. You could have heads, tails, tails, which is that one. You could have tails, heads, heads. I mean, goodness gracious, this is sounding confusing, but I recognize a pattern that each of these things at the end is a possible outcome. So I want to ask, how many of these red ticks are there? So I think there are, there we go. Malcolm agrees it's 8. Okay, so now we go back to the question. What is the probability of obtaining 1 head and 2 tails? Now I look through, this is a tree diagram, and I look and I see where is there, what pathway has 1 head and 2 tails? Now, the first one, HHH, that doesn't have, that has all heads. 2 heads and 1 tail? No, that doesn't, that's not good. Heads, tails, heads? No, that's not exciting. Heads, tails, tails. Oh my goodness, we are in business because we have 1 heads and 2 tails. So that's one way that it's a favorable outcome. Are there any other ones? What about tails, heads, heads? No. What about tails, heads, tails? Ah, we are in business. So that is another possible outcome where we have 2 tails and 1 head. What about the next one? Tails, tails, heads. Oh, we're also in business. So that pathway is also a possible outcome. What about tails, tails, tails? Nope, that's not a favorable outcome. So how many favorable outcomes do we have? So we're going to have 3, and the probability of getting 1 head and 2 tails is going to be C. Now, later in this unit, we are going to do 2 lessons on tree diagrams. So Annie, don't worry. This is just, today is me just opening the conversation. All I did, a tree diagram does the following, but I don't want us to get hung up because we're going to come back to this in lesson 4 and 5. But if you're given an event, how do you visualize the options of tossing a coin? You just go, well, there's option 1, there's option 2. If you toss the coin again, what are the next 2 options? Well, it's still heads and still tails and still heads and still tails. And now you've tossed the coin twice. And then if you toss it 3 times, well, each of these needs to have a heads, tails option. And so what it does is it allows us to visualize the outcomes and the favorable outcomes in a visual way. And just re-watch this again, and you'll see, we'll have lots more practice about this. Today is like my intro day. You're just taking it for a test drive. Okay. Let's try another one a little bit like this. But no, we don't have to go mental. We just have to kind of try and get a sense of what's going on here. And we're going to do this one together. So if I look at the event, I am tossing what is uncertain. I've got a dice and I've got a coin. So I've got 2 different things and they're being thrown together at once. I want to know how many possible outcomes are there if I throw a dice and a coin together. And I want you to try and use the tree diagram idea that I just showed you. So before I even get near this question, I just want to know the main formula for probability is number of possible outcomes over number of favorable outcomes. And so all we are doing is we're trying to understand how many possible outcomes are there if we if we throw a dice and a coin. I'm going to recommend we use some sort of tree, but put the number you think it is in the chat. And it doesn't matter if you're wrong. I just want you to think about it. So if you throw a dice, you have options 1, 2, 3, 4, 5, 6. But that's not all you do. If you were just throwing a dice, you'd have 6 options. But I think each number also has 2 extra options that can occur after it. What are those 2 extra things? Well, it's a coin, and a coin has 2 sides. So I could have heads, tails, And so what I want to know is how many different ways can this experiment end going? Tell me what the number of possible outcomes are for this uncertain event. In the casino of our lives, how many options are there here? We can count them if we want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 possible ways in which the dice and the coin can fall. But now here's the question. The probability of getting a multiple of 3 on the dice and a head on the coin is what? Well, I go to, what is a multiple of 3? Well, 3 is a multiple of 3, and 6 is a multiple of 3. So these are the paths that I have to be on, but it's not enough to be a multiple of 3. There's something else that has to happen. There has to be a head on the coin. So the only pathway that is favorable is that one. And then another pathway that's favorable is that one there. So what we see is that 2, or let me use a darker color, we see that 2 out of the 12 options are favorable. So that's the probability of this happening. There's nothing for 2 out of 12. So what option does it have to be? Well, guys, the answers are rolling in. It's going to be 1/6, which is that one there. Let's do a little vote. Thumbs up if you followed the logic there. Thumbs down if you feel a bit lost by my simple tree diagram ideas. Okay. Now remember, in probability, we often use visual tools to help us. If you are feeling unsure about this tool, that you haven't done it before, remember we're going to do 2 lessons on this tool later on. And remember that you can re-watch this at a later stage. There's no use panicking if you're not getting it yet. I promise there's plenty of time. So trust me, I will take care of you. But for now, I just want to finish off with one more little different thing here. Let's have a look here. There's something different too. Let's have a look at this. Okay. Here's a nice little probability question. And it goes to this idea of what we call a complementary set, which I'll talk about in a future lesson. The probability that my train will be late tomorrow is 1 out of 10. What is the probability that I will not be late? So maybe we could even say it like this. The probability of being late, or L, is 1 out of 10. What is the probability that I will not be late? And in probability, we use a special symbol for not. It just looks like a dash. So probability I will not be late is what? Now remember, if you have an event, and this is something I'll go into more detail next time, you're either late or you're not late. There's only 2 choices. And so if the 1 is 1 out of 10, what are the remaining possible options? Well, it's just going to be 9 out of 10. Because together, the probability of either being late or not late is 1. So we would say the probability of not being late is 9 out of 10, or we could say there's a 90% chance that you won't be late. There's a 10% chance, or 1 in 10 chance you will be late. Now, this is an example in probability of what we call complementary sets. If you imagine a visual description of this, sometimes what we do is we draw, instead of doing an S to show sample space, we draw a little drawing like this, and we might chop it up into 2 pieces. On this side, we might have L, and on this side, we would have L dash, or not being late. And on this side, we have 1 out of 10. And on this side, we have 9 out of 10. And this is called a Venn diagram, and we can use it to represent probabilities. And we know that the sum of the probabilities in the diagram must always add to 1 because they fill the full sample space. Anyway, I'm getting ahead of myself. Let's do one more little question for today. Let's see if I can choose a nice one to finish with. Aha. Okay, let's maybe do 2 more. So if I tell you that the probability of the event A is 3 out of 4, what is the probability of A dash, or the complement of the event A? Now just use the logic so far that A and A dash have to add up to 1. What do we think the probability of the complementary event A happening? So one of the definitions from probability theory, which I will go over in future, is that the probability of a set and its complement must equal to 1. And if you know that this is 3 over 4, and you know that what does that have to be? It's going to have to be 1 out of 4, which is D. Okay, now I'm going to call it a night for tonight. We've done quite a lot. What have we done today? Well, we talked about the definition of probability, how probability is about giving a number to an uncertain event. We spoke about the fundamental formula that we have in place. And we also spoke about visual ways of visualizing the outcomes that we have. And in the next lesson, I'm going to continue to build on ways of looking at possible outcomes and favorable outcomes. Okay. Thank you, Tando. Absolutely. I won't forget the poll. Now we have a bit of time. While you're filling in the poll, I'm happy to answer any questions for students who feel a little bit lost. So pop your hand up if you have a question. Keisha, yeah, let's unmute Keisha. Hi, Keisha. Can you hear me? Let me unmute you, Keisha. Can you hear me?
Okay, thank you. So
yeah.
I still didn't get the N and the S part. Can you please repeat that part?
Okay. Say, if you have S, let's say the possible options are 2, 3, 4, and 5. These are possible options, and the event A is getting 2, 4. Now all the S and the N stuff, the N of S would be 4, and the N of A would be 2. So you're just counting how many bytes are in a set.
So what you're saying is that the S is the
sample space.
The what?
The sample space, or all the possible outcomes.
Okay, so the S is a possible outcome, and then the outcome, and then the A is the what about the A? The what? Sorry.
Cool.
I can't hear.
Okay. I think what we'll carry on in the next. I'm going to go to another question because I think the audio is a little bit bad there. So let me go to Zwandile. What is your question? Hi.
I'm lost in the 3 over 4 to get the answer for this.
Okay. So the most important idea here is something called the probability identity for it's this thing here. So if the probability of A is 3/4, so that's this bit here, the probability of A dash, or the complement, is together with the 3/4 must get to 1. So do you understand why the only way I'll get to 1 is if this is 1/4? Does that make sense to you?
Okay.
So now that's why,
Yes, yeah.
if you, oh, sorry, went too far, but you get the idea. Like, I'm just saying this has to be a quarter.
Yes, I understand now.
Perfect, perfect. All right, we're going to call it a night there to everyone at that point. Thank you so much for your hard work today.